Trent Day, and this is my lab 5 over elastic collisions. It's an elastic collision experiment. Okay, the introduction to this lab. The purpose of this lab was to compare the observed motion of two objects colliding with the predicted motion generated by a GlowScript model. The objects have different masses and collide elastically without sticking together. The two objects in this were two erasers of different masses. One was a heavier eraser made of plastic, and the other one was, I don't know what it made of, but it was lighter. It was just lighter. Okay. One law was Newton's law in elastic collisions. Was elastic collisions followed the Newton's third law, and the conservation of momentum law and kinetic energy. The forces between the objects are equal and opposite, causing the change in momentum. Because I decided it was an elastic collision because it's easier to model, so I did not include. So it was just, I was able to use the conservation kinetic energy. Procedure. First, set up two rolling objects, sliding objects with none masses. Film the collision with a clear reference scale. Import video into tracker to obtain observed positions and velocities. Use initial conditions to build a GlowScript model predicting position and compare using graphs, both using graphs. Formulas used. Momentum conservation, which is P1 plus P2 equals is constant. It's P1, P2 equals P1, P2 final. Okay. Elastic, and then F1 computed to find elastic collision velocity. So equation 2. So m1 minus m2, and then m1 plus m2 to find velocity. And then the experimental graph. Here is the tracker. This shows the exposition of the graph, showing that how when they collided, the heavier mass was mass 1, mass 2, the top one, stayed. It did not move. And there's a picture showing the after collision up there, where the heavier one, which is the one in the center, did not move, while the other one got sent back a foot. Then here's the experimental or the graph of the predicted model. The top right one shows but it shows it at much more of a constant speed that never slows down, and that's also concurrent with it shows them at constant speeds that it keeps on going, which differs from my other graph. And then here's the code that I used. Possible errors for this not matching this graph is friction. So this one slows down because the position flattens out. This one does not. The position keeps on going because in my thing I didn't include friction, so it would constantly keep on going even after collision, so there's no friction. And then air resistance that slowed the object. There is also probably clicking errors, and by clicking, objects may not travel perfectly in one dimensional, and then timing uncertainty in video frames, just human error, stuff like that. And then observations. The observation observed velocities decreased slightly due to non-ideal conditions. Predicted GlowScript model maintains ideal elastic collision behavior. Difference helps identify forces acting. So, for example, there's a lot of friction forces, which is shown through the difference in the two graphs. So that just shows, because this one, it's a linear, and this one kind of flattens out. And then a 1 doesn't mean. 1 doesn't mean if the object does not bounce apart with the predicted speed. It means the real collision is not perfectly elastic. Some energy is lost to sound, heat, rotation, surface deformation. This shows that ideal physics models help predict trends, but real world noise is not. And I'll go back to it. It shows clearly that there was friction involved with the table that I didn't account for. Thank you.